this lesson, we're going to continue talking about slope and how to find the slope of a line. And we are going to find the slope of a line without a graph and without points. You will see that just by looking at an equation of the line, and I have 3 equations right here, you will be able to determine the slope of a line. Now, the very first thing that we need to do in order to determine the slope of a line from an equation is solve for y for each equation. Now, I don't mean for you to actually plug in some ordered pairs in here and create a table that will then lead you to a graph. What I mean is we have to put whatever equation of the line that you have in slope-intercept form. Slope-intercept form is a way to write an equation of the line that begins with y equals. So that's why I said we're going to solve for y. I'm going to use the graph as my workspace for now. What I want to do is I want to keep my y by itself on one side and everything else on the other side. So that means that I have to move all of this to the other side of the equal sign. So I'm going to start by moving the 4x. If I add 4x to each side of the equal sign, the left side is going to give me a 0. So now I have 8y equals 4x plus 24. The next step is to move the 8 to the other side, and 8 is being multiplied times y. So if I do the inverse and divide each side of the equal sign by 8, I'm left with 1y on this side. Now, because I'm dividing all the terms are on the other side of the equal sign by 8, that means that I can separate each term on its own. And that will make it easier for me to simplify. So when I do that, I can simplify this to 1/2 x, and I can simplify the next term to 3. And so now I have my equation y equals 1/2 x plus 3, which is equivalent to our original equation of the line. Now, the reason we want to put it in slope-intercept form is not just to be able to find the value, but also if we want to check our work, it's just a lot easier to graph an equation if it's in slope-intercept form, because we know that this is going to be our y-intercept and this is going to be our slope. So if I were to go to my graph and graph it, I know that my y-intercept is going to be at a 3 and my slope is going to be 1/2. That means that I have to go up 1 unit and to the left 2 units, 1, 2, and my next point is going to be there. And then from that point, I can go up 1 unit and to the left 2 units to get my third point. And I can continue to do that until I have enough points where I'm comfortable drawing a line. And that's why having an equation of a line in slope-intercept form makes it a lot easier to check your work, to figure out what the slope is, and to graph a line. Let's move on to equation number 2. Again, I want to move everything that is on this side of the equal sign to the other side so that I isolate my y by itself. So my slope is going to be -2/3 and my y-intercept is a -2. So I can check my work by first plotting my y-intercept and then using my slope. This is -2, so that means I'm going to go down instead of up 2 units and to the right 3. I'm going to graph the line. Another way to also check to see if that is the correct line is to simply grab one of these points that you just graphed and plug it in. So I'm going to graph this point, that happens to be a 6, -6, and plug it into my original equation. And that should be equal to -6. So that means that that is the correct line, that's the correct slope, and we did all the math correctly. I want to move everything but the y to the other side. So I'm going to start by subtracting the 5x from each side. That gives me a 0. And then I'm left with -1y equals -5x plus 4. Then I'm going to divide each side by -1. That way I have a +1. And that gives me a 5x minus 4. My y-intercept is a -4 and my slope is a 5.